I'm James Messer, and welcome to Professor Messer's SY0-501 Security Plus Take 10 Challenge number 2. If you would like to follow along with this challenge online, you can visit us at professormesser.com/take10 and follow along one question after the other, or you can simply watch this video and we'll go from the very beginning to the very end of this Take 10 Challenge number 2. As you go through this online, you may notice that the questions are in the same order as I present here, but the answers may be randomized. I'll give you the question and the answers here. I'll start a 7-second timer, and then you can decide if you need to pause the video for a little bit more time. At the end of that 7 seconds, I'll give you the answer. If you need to jump to a particular question or answer, I'll put the timestamps for that in the YouTube video description below. Our SY0-501 Security Plus Take 10 Challenge number 2 starts off with this question: which of the following would best describe data in use? Would that be a switch forwards frame to a router? Would it be that a point-of-sale terminal encrypts a credit card number? Would it be that customer information is transmitted across an IPsec tunnel? Would it be that encrypted data is stored in a SQL database? Or would it be that a laptop drive is configured for whole disk encryption? We'll get the answer in 7 seconds. And the answer is a point-of-sale terminal encrypts a credit card number. Data in use is a particular state of data that is referring to the use of that data inside of memory. So this would be system RAM. It would be inside of a CPU. Anytime we're doing any type of transaction or working with that data, it has to be in memory and it has to be in a CPU. It could also be in a cache. So if you find data in any of those places, it's categorized as data in use. It's in this section of data that some of our most private data is at risk, because we have to decrypt data to be able to do any type of analysis or even view it, and that decryption takes place in the memory and in the CPU of our system. If you're a very good attacker, you're able to pick out this private or confidential information right out of the memory of our system. In fact, that's what happened in 2013, where Target had an enormous credit card breach, and over 110 million credit cards were breached because the bad guys knew to go into memory where the data was in use and be able to pull those credit cards directly out of that system RAM. The two other types of states of data you might run into are data in transit, that is sometimes called data in motion, and that's data that's being sent across a network. And there's also data at rest, where data is being stored onto a file on a storage device. All of the other options that we had available were either data in transit or data at rest. A switch forwarding a frame to a router is data in motion or data in transit. Customer information is transmitted across an IPsec tunnel, also data in transit. Encrypted data is stored in a SQL database, that is data at rest. And a laptop drive configured for whole disk encryption, that would also be data at rest. The only option here that would describe data in use is a point-of-sale terminal encrypting a credit card number. Question 2. An attacker has determined that they can intentionally overwrite an area of memory to perform an exploit. Which of these would best describe this exploitation method? Would that be driver manipulation, a buffer overflow, data injection, man in the middle, or cross-site request forgery? The answer in 7 seconds. Overwriting memory, usually to find some way to perform some type of exploit, is indeed a buffer overflow. A buffer overflow is not something that should normally happen. Developers, when they're writing their software, should put limits in place that would prevent somebody from randomly overwriting areas of memory that they would not normally have access to. This is not a simple exploit to be able to take advantage of, and in fact, it's very unusual to find the right combination of things where you're not only able to overwrite or have that buffer overwritten, but overwrite it in a way that allows you to have a certain type of access to that system. For the attackers, their best possible scenario is to have all of those things line up and have it line up in a way that they're able to perform that same buffer overflow over and over again and have exactly the same outcome. Here's a very simple type of buffer overflow. I have two variables, a variable A and a variable B, and they sit right next to each other in memory. Variable A has nothing assigned to it, and variable B has the value 1979 associated with it. Well, if I'm able to overwrite variable B so that it's able to perform a particular function for me, one of the ways I can do that is instead of going directly to variable B, I can overwrite variable A with too much information. And in fact, here I'm putting in the value excessive, EXCESSIV, and then the E is spilling off into this other variable, which then changes variable B to be 25,856. So you can see by changing variable A, we were somehow able to overflow into variable B and modify what that variable really should be. Driver manipulation involves modifying or implementing a specific type of driver change on a system. It's not regarding overwriting an area of memory. Data injection involves putting our own code into some existing code, but it does not necessarily require that you overwrite an area of memory. Man in the middle is a type of attack where a third party can sit between two systems, and without those two systems knowing it, they're able to both see and in some cases inject their own data. In a man in the middle situation, we also are not necessarily overwriting an area of memory. And a cross-site request forgery is another way to get our own code into a system, but it again does not require that we overwrite a section of memory to be able to do that. Question number 3. A security administrator would like to limit internal users from directly communicating to external websites. Which of these security technologies would be the best choice for this objective? Would it be a firewall, an IPS, a load balancer, a VPN concentrator, or a proxy? The answer in 7 seconds. And the answer is a proxy. Proxies are commonly used as a security mechanism, and when you're using a forward proxy, this is sometimes called an internal proxy, the proxy sits inside of your organization. Users then make their requests to the proxy, and the proxy then makes the request out to the website that's somewhere on the internet. That website on the internet responds back to the proxy. The proxy evaluates the response, makes sure that the information is secure, there's no type of exploit, there's nothing malicious inside of it, and if everything checks out, it sends that response to the user. In this process, you can see the user is communicating to the proxy is communicating to the web server on the internet, but the user is never able to directly connect and communicate to those services on the internet. Firewalls are great technologies if you need to restrict access to certain parts of the network or to allow or disallow traffic flows, but they're not necessarily the best choice if you would like to limit internal users from directly communicating to external websites. That really does fall into the qualification of a proxy. Intrusion prevention systems are designed to prevent any type of known vulnerability or known type of attack. They are not designed to provide controls for users that are communicating to websites. Load balancers are a great way to provide uptime and availability of services, but they're not a security tool that restricts people's access to external websites. And VPN concentrators are useful if you need a protected and encrypted tunnel between two locations, but they're not used as a security tool to limit someone's direct access to a web server. Question number 4, which of these best describes TPM functionality? Is that application blacklisting, EMI prevention, hardware root of trust, reverse proxy, or EAL4? The answer in 7 seconds. And if you chose hardware root of trust, then you're probably familiar with a TPM. Everything in IT security is based on trust. If we're using a particular encryption mechanism to protect our data, then we're trusting that that encryption is very strong. If we are connecting to a web server, then we're trusting that the certificate on that web server is one that is telling us that we are connecting to the right site, and therefore we can trust the data that we find on that web server. On our local machine, the trust begins with a piece of hardware called a Trusted Platform Module, or a TPM. This is usually a module or a piece of hardware that is connected to the motherboard of your computer. This hardware allows us to perform cryptographic services, and we might even store private information such as private keys or certificates on the TPM itself. We often refer to that point where all of that trust begins as our hardware root of trust. In this case, the only answer that really made any sense for TPMs is hardware root of trust. Application blacklisting is something that allows us to access or not access certain applications. That's not associated with TPM functionality. Electromagnetic interference prevention is obviously important with computers, but that is not the responsibility of a TPM. Reverse proxy is a way to allow or disallow access to websites or services, but it is not something that TPM is responsible for. And EAL4, or Evaluation Assurance Level 4, is a way to qualify how secure a particular system might be, and that is not the responsibility either of a TPM. Question number 5, which of the following would be a disadvantage to using PAP during authentication? Only operates over dial-up lines. The passwords are stored as a salted hash. It must be used with a third-party trust. The credentials are passed in the clear, or the password hash is easy to brute force. The answer in 7 seconds. And with PAP, the most significant disadvantage to using that mechanism is that the credentials are passed in the clear. PAP stands for the Password Authentication Protocol. It's a mechanism that a client might use to be able to log into another device, and username and password information is passed across the network using this Password Authentication Protocol. One of the disadvantages of PAP, though, is that it is sent in the clear. So if you don't have a mechanism to somehow encrypt or hash that password as a secondary function, PAP will simply send your username and password across the network in the clear, and anyone who happens to be monitoring that network or capturing those packets would be able to see our username and our password being sent in the clear because we're using the Password Authentication Protocol. PAP can be used on the network or with dial-up lines. It is not exclusive to dial-up lines, so it would not be our first option on this list. Passwords are stored as a salted hash. They are certainly not automatically stored as a salted hash. If you are using PAP, it's probably a good idea to do that as a secondary function so that you don't send that information in the clear over the network using PAP. Must be used with a third-party trust. There is no requirement that PAP should be used with a third-party trust. And the password hash is easy to brute force. In the case of PAP, there is no password hash, so therefore there's nothing that you would need to brute force. Our answer here is that the credentials are indeed passed in the clear. That is the primary disadvantage when you're using the Password Authentication Protocol. We're halfway through this Take 10 challenge, and if you like these questions, you're really going to like my SY0-501 Security Plus practice exams. These are 3 full 90-question practice exams. It's a book that's over 400 pages long and includes both performance-based questions and multiple-choice-based questions. You can purchase this as either a digital edition PDF or a physical edition book. If you're using the PDF, I put links into the book itself. So once you read a question and you think you know what the answer is, you can jump directly to the details page, which tells you what the proper answer is and gives you an explanation. Perhaps more importantly, I tell you what the incorrect answers are, and I tell you why each answer is incorrect. And lastly, at the bottom, I give you a description of where the topic for this question came from. You can find exactly the right video to go to and either click on the link or use your phone to be able to click the QR code reader and be able to go directly to that video. Using the back button, I can now go back to the original question and continue with my testing process. If you'd like to learn more information, you can visit my website at professormesser.com/securitype. That stands for Security Practice Exams. Question number 6. Which data label would be most associated with patient records from a medical doctor? Would that be PHI, PII, NDA, DSS, or PCI? The answer, 7 seconds. And since we're dealing with medicine, the answer here is PHI. When you're dealing with sensitive data, there are different labels that you can associate with those data types. Proprietary data would be data that is the property of an organization. But even more specifically, data that is PII stands for personally identifiable information. This might be someone's address or their maiden name or some type of biometric information. When you're dealing with healthcare, then you're dealing with PHI, which is protected health information, which might be your health status, your health record information, or anything else associated with healthcare. And that's why in this case it would be PHI. We know that it would not be PII, which is the personally identifiable information. It would also not be non-disclosure agreement, which is a contractual agreement between two parties that is not associated with medical doctor-patient records. DSS, or Data Security Standard, is a standard commonly associated with the PCI, or payment card industry. And those two things work together to make sure that our credit card information remains secure on the network. Question 7 asks, which of the following would not commonly be associated with a server certificate chain? Would it be intermediate certificates, a private key, a root CA certificate, a server certificate, or a root CA certificate hash? If you know the answer, you've got 7 seconds. And it's the private key that we would not commonly associate with a server certificate chain. When you're trying to verify if a particular web server certificate is valid, you need to, of course, look at that certificate. You also need to evaluate the original certificate authority. But very commonly, there are also intermediate steps between that server and the CA, and you also have to check that entire chain of certificates. We call that our chain of trust. You would start first evaluating the SSL certificate that is on the existing server, and then you would go back and look at the root certificate authority's certificate, and then any intermediate certificates in between. Those are the chain certificates or intermediate certificates that we need to evaluate. We need to make sure that all of those certificates are valid. We have to make sure that everything in the chain lines up properly. If it doesn't, then the certificate that's on the web server is not a valid certificate. The one item that you would never want to make available for people to see or evaluate is the private key. They can look at the intermediate certificates, the root CA certificate, the certificate that's on your server, and even the hashes that are created from the root CA, but you would never want someone to be able to see your private key. Question number 8. An attacker has infected a government healthcare reporting website with malware in an effort to gain access to a hospital network. When the hospital visits the government site, the malware will attempt to infect the hospital computer. Which of the following would best describe this attack type? Would it be a man in the middle, a watering hole, a data injection, a hoax, or a cross-site request forgery? 7 seconds. Our answer here is a watering hole. A watering hole attack is commonly used when an attacker has not been able to get inside of a particular site. So instead, they'll try to get to that site by going through someone else. They'll effectively go to the watering hole, wait for the user to arrive, and then poison the water to gain access to that particular network. In some cases, they're not even being particular. They're just infecting everyone who happens to visit that site, and they're hoping eventually that the one they're looking for will visit and take a drink from their infected water. In the case of a man-in-the-middle attack, there are 3 entities involved. There are the 2 that are communicating, and then a third that is sitting in the middle of the communication, usually in real time. In the case of a watering hole attack, there are really only 2 active participants, the person who is visiting the watering hole and then the watering hole itself. Data injection implies that we are adding information or putting our own information into a conversation going back and forth. And although that could be part of the exploit that is taking place on the watering hole, it does not describe this entire scenario of a website that is being infected so that a third party can be infected from there. A hoax is a type of attack that is not actually occurring, and in our example here, this is one that really is a malware infection that is occurring. And lastly, a cross-site request forgery may describe the entire process that took place to get the malware on that system, but it is not describing this process of going to a third party and infecting that third party to gain access. That is very specifically talking about a watering hole attack. Question number 9. During a scheduled event, a security administrator was able to exploit a known vulnerability on a server to gain root access. Which of the following would best describe this event? Is it a DOS, a man-in-the-middle, spoofing, a penetration test, or a vulnerability scan? The answer in 7 seconds. If you've gained access to a system, then you've performed a penetration test. With penetration testing, we are simulating a real attack. We're trying to gain access to a system. This is very similar to vulnerability scanning, but a vulnerability scan is simply identifying that a potential exploit exists, whereas with penetration testing, we're trying to take advantage of that exploit. This is something that many organizations will do to make sure that their systems are secure. There's a good best practices on the internet from the National Institute of Standards and Technology. This is a technical guide to information security testing and assessment, and you can find that at professormesser.link/800115. A DOS, or denial of service attack, is an attack that makes a service unavailable for anyone else. It does not describe someone gaining access to a system, especially root access. Man-in-the-middle describes a third party that is accessing information that's being sent between two other devices. In this case, an administrator simply using a known vulnerability. There's not a third party involved, so this would not be man-in-the-middle. That security administrator didn't have to change their IP addresses or pretend to be someone else. So in this case, it would not be spoofing, and this would not be a vulnerability scan because we actively exploited that vulnerability, making this a penetration test. And question 10, a security administrator needs to create a report each day that shows the number of invalid login attempts across all of their servers. Which of these would be the best way to provide this information? Would it be DLP, a SIM, a NAC, a firewall, or a proxy? The answer in 7 seconds. If you're creating a report from all of these different resources, then you're probably doing that on a SIM. We pronounce it SIM, but it's really SIEM. That's a security information and event management device. It is usually a device that is consolidating log files from many different devices, from switches, routers, firewalls, intrusion prevention systems, servers, and almost anything else you can think of. Once the SIM receives all of this data, it's able to parse that together and give you information about alerts and reports. It can aggregate that data for doing long-term reporting and long-term storage. It can correlate data together that normally you would not expect to be able to correlate. And if you need to perform any type of forensic analysis, you can use a SIM because it has all of that data available. DLP is a data loss prevention system which allows you to look for private or confidential information being sent from one point to another. It is not a device that creates reports based on invalid login attempts. A NAC, or network access control device, is one that allows or disallows access to the network based on a particular set of criteria, a username, a password, or perhaps the type of software that might be loaded on a system. The NAC itself is not a way to provide a report of invalid login attempts across all different servers on the network. A firewall generally does not provide any type of authentication and certainly not centralized reporting, so that would not be the best choice for this particular task. And a proxy is very good for allowing or disallowing direct access to devices over the network, but it's not very good for reporting on any type of login problems. The best way to provide this information is with a security information and event manager. We've got lots more Take 10 challenges on our site. Feel free to visit at professormesser.com/take10. Don't forget that we have a weekly Security Plus pop quiz question and all of our Security Plus videos online. You can find all of those at professormesser.com/YouTube/Twitter and /Instagram. And if you'd like to learn more about our practice exams, visit our website at professormesser.com/securitype. Thanks for watching. We'll see you on the next Take 10 Challenge.